Here we go. We're going to fill in the blank to write a perfect square trinomial, and then we're going to factor it. So what is a perfect square trinomial? Well, it's a trinomial that's a perfect square. Okay, so when I talk about a perfect square, you might be thinking geometrically like, oh, there's a square, and look, it has 4 sides. But I'm talking about a perfect square like 4, which is 2 times 2, right? So like 2 squared is 4, or 3 squared is 9, and 1 squared is 1. It's a perfect square. Kind of boring, but it's a perfect square. So these are perfect squares, so that tells me that this number is going to be a perfect square. Now, in the real world, that doesn't always happen because this could be all kinds of crazy stuff, which would mean that this is not a perfect square. But for the problems we're going to do right now, this is going to be a nice, neat, pretty number. That'll help us gain an understanding of it. So our number here had better be a perfect square. Now, it can't just be any perfect square. It needs to be a perfect square that makes this thing factorable into, well, let me put the lid on this one. This is going to turn into this, and this is going to turn into that, which tells me this. So whenever I factor it, I'm going to have x times x, and then whatever I have here, it better be the same thing in order for me to be able to say, oh look, I have 2 of them. So this is going to be x, let's go ahead and say plus something and x plus something. And if I was to multiply these 2 numbers, I would get that. If I was to add them, I get that. Now this is where things get pretty easy. If I was to add these 2 numbers, I'd get 6, and they're the same number. Well, 2 numbers add together to give you 6, and they're the same number. Well, just cut your 6 in half. So there we go. It's 3 and 3, and this works. So like x squared plus 3x plus 3x, so 3x and 3x makes 6x. And then 3 and 3 is going to make, 9. That's what goes in the blank. And so then this becomes x plus 3 squared. Okay. Now in just a second we're going to figure out the shortcut for what goes in that blank, but let's do another one, and the next one actually looks exactly like the first one with the exception of a sign change. So same problem, just that's a minus this time. So I wonder how that affects it. So well, the next step is going to look like this, and the final step is going to look like this. Now in just a second you're probably going to say, well, why don't I just skip from here and go straight to here? Go for it, I'm with you. I'm not going to do that yet, but you can. So x and x, no secrets there. I need 2 numbers that add together to give me that. They better be the same thing. So it's going to be 3 and 3, but if I'm going to add 3 and 3, I get 6. I don't want 6, I want -6. So maybe -3 plus -3 would give me that -6. Okay, so this really makes it x minus 3, and that is squared. Now, let's figure out what goes here. -3 times -3 is still 9. So I fill in the same thing in both blanks regardless of this sign here in the middle. Okay, so if you've picked up on the shortcut, great. If you haven't, that's okay. We'll keep going. And in just a second, we're going to actually get to the shortcut. I'm going to leave that one up here just so I can point at it in a second, and we'll use that as a reference. So the next one is going to say x squared minus 10x plus something. And I'm going to write the middle step, although some of you may want to jump straight down to here, and I'm okay with that. That's perfectly fine. You know it's going to go here. But just for the sake of explanation, here goes. So x and x and x there. All right. I need 2 numbers that add together to give me 10. Now, if you're watching this and you're bored out of your mind because you already know what goes in this blank, write it, fast forward, you got this. You're fine. But I do want to walk you through the process one more time before we understand, before we figure out the shortcut, right? We have to know where the shortcut comes from. So 2 numbers multiply to give me 2 numbers add together to give me -10. Well, they have to be the same number, so it better be 5 and 5. So it's the opposite. It's negative because I have to add to get a -10, right? So x minus 5, and that's squared. Well, -5 times -5 is 25. So let's start finding a shortcut. And if I'm going to find a shortcut for this thing, then I need to kind of look at my pattern and see what's going on here. So I'm going to erase this middle step because it might be necessary to start skipping it here in just a second. But how do I turn a 6 into a 9? How do you turn a 10 into a 25? Like, whatever I do to turn a 6 into a 9 better be the same thing I do to turn a 10 into a 25. So well, let's look at the number in the middle, and that'll sort of help us. The number in the middle of the process. How do you turn a 6 into a 3? You took half of it. How do you turn a 3 into a 9? You multiply it by itself. Okay, so let me say that again. Knowing that this is my end result, how do I turn this into this? I took half. So I'm going to write that down. Let me write that in this green that will clash with that green. So I will half the number in the middle of this trinomial, and then I'm going to do something else to it. So I'm going to take half of it, and then how do I turn a 3 into a 9? Well, I multiply it by itself, so I square it. Now, if these clashing greens are driving you nuts, don't worry. I'm going to erase this soon, but I'll probably leave the other green up there. So we're going to take half of the number in the middle, and then we're going to square it. Now, when I take half of it, I keep the negative, but whenever I square a negative, negative times a negative is always positive. So this is always going to say plus. Negative times a negative is going to be a positive. And again, that's going to always be a positive unless we go into the realm of imaginary numbers, and we're not going to play that game right now. So half of 10, or half of negative 10 is negative 5. If I was to square a negative 5, I'd get positive 25. Okay, so we're going to take half and square it. Take the number in the middle, and you take half, and then you square it. So years ago, I had a math song that I had written that went along with a different concept, different idea, but it actually did cover that idea about filling in that blank, completing the square. X squared plus 2x plus something. Okay, and it was a rap song, and it said, I take the number with my x, then I half it and square it. That's all the rapping you're going to hear me do. That was it. But if I take half of that and then I square it, I take the number with my x, not the x squared, the x. I take the number with my x, then I half it. Okay, that'd be 10. That's positive 10. Why don't we just jump down to the real answer, right? I take the number with my x, then I half it and square it. I'm the kind of student little homies wanna be like, with my nose in a book, working hard till I get it right. Okay, that's all the rapping you'll get. Take half of it and then I square it and I get a 100. Been spending most our lives living in quadratic paradise. I'm gonna take half of 2. I get a 1. Let's go ahead and write that, because that's where we're going with this thing. I take half of it and then I square it. I take the number with my x, then I half it and square it. 1 squared is 1. All right, fantastic. So that brings us to the end of this. If, and I'm just throwing this out here, if this was a negative, that would be a negative, but that would still be a positive, right? Okay, so that brings us to the end of this big idea of how to complete the square to make a perfect square trinomial. Okay, let's talk about a definition here for a second. A perfect square trinomial, got all kinds of colors going on up here. Perfect square trinomial is, well, it's a trinomial that is a perfect square, meaning you can factor it into something squared, which is exactly what we've done. So that idea is going to help us as we jump back into this idea of writing equations of circles.